whenever light falls on any particle, you can say. So after falling on the particle, the light spreads in all the direction. Okay, so you can write when the light when light uh, falls on the particles in its path, then light spread in all possible directions. Or you can say the amount of scattering the amount of scattering depends on size of particle. Okay, so the amount of scattering depends on the size of the particle and wavelength of the light. Wavelength of light. Okay, so this is the scattering of light simply. After that, we will have Tyndall effect. So Tyndall effect, you can say, see this picture. Here, sunlight is coming through uh, the trees. Okay, sunlight is coming through the trees, and here, na, you can see this portion, white color portion. Okay, here, uh, there are the particles of, or you can say there are the particles or the water droplets are there of moisture. Okay, so when the light from the sun is striking on those particles, the path of those moisture particles becoming visible. Okay, so that is why this is looking like this. And so now what is Tyndall effect? Tyndall effect is basically the scattering of light by particle in its path is called the Tyndall effect. For example, light is coming from the sun, and in the path of the light there are the moisture particles, and due to the and due to that the light is scattering in all the direction. You can see here. Okay, so the scattering of light by particle in its path is called Tyndall effect. For example, sunlight. There is one more example. Sunlight becomes visible as it passes through the dust particle in the room. So I do not know whether you have seen or not. If there is a room, and that room is a dusty room. In a room there is a little bit of dust, and when through the window the sunlight comes, and when the sunlight strikes on the particle present in the room, then the path of the motion of the particles or dust particle becomes visible. Okay, so that is known as the Tyndall effect. That is known as the Tyndall effect. For example, you can take one more example here. Suppose this is the normal solution, like you can say this is a water and salt solution. So salt is completely dissolvable in water. Okay, so salt is completely dissolvable in water, and this is the colloidal solution. Colloidal solution means there are some particles which are not completely dissolvable. These particles are just suspended particles. So what is happening here when a ray of light, or you are just the light is coming like this, you can see. So here no path of the particle is visible, no particle is visible. But here, what is happening, as the size of the particles are greater as compared to the hair, and the light is striking on those particles. Okay, so the light is striking on those particles, and due to that, what is happening? Due to the scattering of light on the particle present in the in this colloidal solution, okay, the scattering of light is taking place, and due to the scattering of the light, the particles are visible here, and this is known as the Tyndall effect. The scattering of light due to the the scattering of light by the particle in its path is known as the Tyndall effect. Okay, sir.
Yes, sir.
So in this case, in the path of the light, there are the moisture particles, okay, or you can say small water droplets. Here in the path of the light, now if I am asking that here, which is responsible for the scattering of light, the particles of this solution, suspended particles of this solution, and here due to the which is responsible for the scattering of light, the moisture present in the air. And Tyndall effect is the scattering of the light by particles in its path is called the Tyndall effect. Sunlight becomes visible as it passes through the dust particle in the room. So in the room there will be dust particles. So there the scattering of light due to the dust particle. So the path or the motion of the dust particles becomes visible. After that, in sunlight, white light is there. In sunlight is a white light, you can say. So basically, in sunlight, red light and blue light are the predominant color. I mean, mostly you can say in the sunlight there is a red and the blue light. Large amount of the red and the blue light is present. Other color lights are also present, but mostly the red and the blue light. Okay, so you can say in white light, red and the blue are very predominant. We know that the wavelength of the red light is maximum. So you can say the red light has the maximum wavelength and the blue light has the small wavelength. When we are moving from red to blue, the wavelength decreases. Okay. When we are moving from red to violet, wavelength decreases. Okay. So blue light have the short wavelength. So due to the short wavelength of the blue light, scattering is more. Blue light scattering is more. And red light has the large wavelength. So if the wavelength is large, then the scattering is less. So we can say the scattering of light is directly proportional to the is inversely proportional to the wavelength. If the wavelength is large, then the scattering of light is less. Okay. So basically, the scattering of light depending upon number one, the size of the particles. Number two, the wavelength of the light. You can see here. Here, the size of the particle is just different as from here. So here, the path of the particles is becoming visible, and scattering of light is taking place here. Okay. So this is the Tyndall effect, and remember this point. Now you can note down this. Please write only do not you cannot make this diagram, only just write the effect produced by the scattering of sunlight by the earth atmosphere. Number one, the sky is blue. Number two, the sunset and the sunrise are red. You can write this only, okay, this text only, and this also.
Scroll down.
So scattering of light is due to the light falling on some particles in its path.
Scroll down.
Completed. Azaan, completed.
Yes, sir.
Okay, now we will discuss why the sky is blue. We will discuss now why the sky is blue. Basically, the reason behind the sky is blue is due to the scattering of light. So what happens? Light comes from the sun, and in that light, we know from the dispersion of light, there are 7 colors. So what happens in the atmosphere? There are the particles. There are the particles of air in the atmosphere. So I told you, if there are the particles in the path of the light, okay, then the scattering of light takes place, obviously. And the scattering of light will depends upon the size of the particle and the wavelength of the light. And we know that the wavelength, and one more point here, in the sunlight, the predominant colors are, what are the predominant color are there in the sunlight? Red and blue. So the
Yes.
okay, now focus on the colors red and blue. So red color have the large wavelength. So due to the particles in the path, due to the particles in the path, these are the particles, this is light. So the scattering of red color light is almost like, almost you can say negligible, means uh, is very less as compared to the scattering of the blue light. Why blue light is scattering more? Due to the atmospheric particle present in the air, because the wavelength of the blue light is more. So from the sunlight, light is coming, and that light, when it strike on the particles present in the atmosphere, uh, the mostly the blue light scatter more, okay, as compared to the red light. You can say at least 10 times more than the red light. The scattering of the blue light is there. Okay, and so what happens? Some of the blue light, na, they are in the atmosphere is scattered, and due to that, the sky appears blue. You can see in this figure. See this. This is the sun, and this is the, so what? This is the atmosphere. Okay? And in the atmosphere, we know there are some molecules in the air. So sunlight is going in all the directions. Suppose going in this direction, in this direction, in this direction. So here are the particles in the atmosphere, and due to the particles, you can see here little of blue light is scattered. So blue light is scattered here. Here also the blue light is scattered. Here also the blue light is scattered. Why the blue light is scattering? Because the wavelength of the blue light is less as compared to the red light. Red light also is scattered. I'm not saying red light is not scattering at all, but as compared to the blue light, red light scattering is very 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 less. So mostly the scattering of blue light takes place around there. So that is why the sky appears blue. Okay. So write down this. Means only you can just draw this figure. So there are the air molecules in the atmosphere, and when the light strikes on those air molecules, the scattering of the blue light takes place. and due to that the sky appears blue. Okay, Azaan, got it?
Yes, sir.
Not all the blue light is scattered. You can see here the little of blue light is scattered. Okay. So remember this point also. If all the blue light will be scattered there, present in the sunlight, then we are not able to get the blue color on this earth. So little of blue light is scattered there. Draw the figure and uh, write the information also in the figure. If you will draw this figure in the examination, you will get full marks. If you will draw this figure properly in the exam. Why the sky is blue? They are asking.
Done, sir.
Okay, so this chapter is finished now. Now we will start the electricity. So electricity, we know is very important part. Okay. So you can see this picture first. See, this is some city, and the effect of electricity on the city means everywhere there is lighting, and there are several kinds of works, very important works that are going on due to the presence of electricity. So we cannot right now, means at this time in 2022, we cannot imagine a life without the electricity. So electricity is very important part of our life. So we will see what is electricity in this chapter, and related to this we will study charge, we will study current, we will study electric potential, resistance, and all that. So we can now say that the electricity is very essential part of our life. Okay. Now I will start from the electric charge. I will start from the electric charge. So electric charge, we know there are two types of charge: positive charge and negative charge. Hmm? Charge, there is a term like mass, we have mass. Hmm? Like mass, there is a quantity charge. Basically, charge is the fundamental or intrinsic property of a body. There are two types of charge: positive charge and the negative charge. So when in earlier days, they find it out that there are the charge, there are something called charge, and there are only two types of charge available on any body: positive charge and the negative charge. So earlier they say positive charge as by convention they say the charge on the glass rod due to rubbing it with silk cloth. So what does it mean? If you have a glass rod, and one more thing I want to tell you, if just you take a pen and take few pieces of paper, take few pieces of the paper, small pieces of paper, take a comb, take a comb, and from that comb, suppose in my hand there are the pieces of the paper and this is the comb. So when I uh, take this comb near to the pieces, so there will be no effect on the um, pieces of paper, small pieces of paper. So after that, what will happen? After that, what I will do? I will rub this comb with my hair, and after that, we will see. We will see. Just try to imagine these pieces of paper will try to attract, or you can say the comb will attract these pieces. Why this happens? Why this happens? So the reason is, initially you have taken the comb. Initially there is no charge on the comb. So if there is no charge on the comb, basically what happens na, due to the charge, mm, there is a force known as the electrostatic force arises. So initially there is no charge on the comb, and due to that, what happens when you are taking the comb near to the pieces? So there is no force of attraction, as there is no charge on the comb. After that, what happens when you rub the comb? This comb gets some charge, and due to that charge, this comb is able to attract the pieces of paper. So somehow they find it out that whenever take a glass rod and rub that glass rod with a silk cloth, so you will get the positive charge. The charge on the glass rod due to rubbing it with silk cloth, you will get the positive charge by convention. Convention means in earlier days it is They say uh, negative charge. The charge on the ebonite rod. Now we know what is the positive charge. Charge on the proton. In atom, there are electrons and protons. Electrons are negatively charged and protons are positively charged. We will study that. So by convention, what is negative charge? The charge on the ebonite rod rubbed with a woolen cloth. If you have a ebonite rod and if you are rubbing it with a woolen cloth, then that ebonite rod, hmm, the ebonite rod will get the negative charge. Here, the glass rod rubbed with the silk cloth will get the positive charge. This thing I think you should know. Opposite charges or unlike charges attract each other. Positive and negative charges attract. We know very well. And if you are taking the like charges like positive and positive, negative and negative, I suppose I am having two positive charges. So they will try to repel each other. They will try to repel each other. So the answer of this question you will get in the test 12th class. Why this happens? So a negative charge and repel, positive and positive charge will repel. Okay. So the this is the negative charge. Negative charge. And this is positive charge. So this charge will be on some body, huh? Charge will be on some body means you can say this is a body having a negative charge and this is another body having the negative charge. So both the bodies will repel each other. Hmm? Charge will be on the body. Like I am saying, two masses are just attracting each other. Newton's law of gravitation. You have, I think, do you know Newton's law of gravity? Azaan,
Yes, sir.
means I am saying, do you know what is the Newton's law of gravitation?
No, sir.
Okay. So actually, Newton's law of gravitation says that means every masses attract each other. There is a force of attraction between each and every masses. Between these two pen also, there is the force of attraction, but that force is very, very, very small. So that is that force is not visible here. Means the effect of that force is not visible here. Like two charges or will attract or repel each other accordingly if they are negative or if they are positive. Now unit of the charge, like unit of there are length, the unit of length is meter. The unit of what is the unit of force? SI unit of force? What is the SI unit of force?
Sir, can you say again?
I am saying what is the SI unit of force?
Sir, SI unit of force is Newton.
Hmm. What is the SI unit of length?
Length, I don't know, sir.
You don't know how means in which term we measure length.
Sir,
What is your
meter
height?
or centimeter.
Yeah, meter, centimeter, SI unit. Means meter is the SI unit. So, okay. So, can you tell me what is the unit of refractive index?
Uh, Sir,
Mhm.
refractive index doesn't have any.
Right. Refractive index do not have any unit because the refractive index of any medium is the ratio of the speed of light in vacuum divided by the speed of light in that medium. So that means it do not have any medium. Okay. So refractive index mu is the refractive index. So speed of light here is also a speed in numerator. Here is also a speed. So both have the unit meter per second and meter per second. So that is why the refractive index do not have any unitless quantity, means refractive index is a unit. Okay, so by the way, the unit of charge, I will talk about the SI unit of charge is Coulomb. Basically, Coulomb is the name of the scientist. So in 12th class, if you will have the physics, you will study Coulomb's law. Okay, so that is the analogy with the Newton's law of gravitation. Okay, so unit of charge is Coulomb. Okay, so you can write down now. An electric charge throughout this chapter I will represent with small q. So the main thing is charge, two types of charge. If opposite charges attract each other, similar charges repel each other. And unit of charge, SI unit of charge is Coulomb. So actually, I am not going in the history, means how they find it out that there is charge and all that. So we have to stick to our syllabus. So I have given one example also of the comb and the tiny pieces of the paper. So you can relate from that example. Azaan, is my voice cracking or it's okay? Completed, Azaan?
No, sir. 1 minute. Done, sir.
Completed. This also completed. Unit of charge.
Yes, sir.
Okay, so unit of charge is coulomb. And suppose if someone is saying what is 1 coulomb. Suppose someone is saying what is 1 coulomb. So 1 coulomb is basically the force of attraction or force of interaction between two unit charges, that those charges are placed at a distance of 1 meter. What does it mean? See, if they are saying what is 1 coulomb, one charge is there here. Suppose this charge Q is equal to 1 coulomb. Here is another charge. This is also of 1 coulomb. This is also of 1 coulomb. So now these two charges either of same nature, means both these charges either positive or either both these charges will be negative. So you can say here if both the charges are positive, then there will be the force of attraction. If both the charges are positive, then there will be the force of repulsion. And if both the charges are negative, then there will be the force of attraction. So we will not say the force of attraction and force of repulsion. We will say force of interaction. So for defining 1 coulomb, 1 coulomb, you can define the quantity of charge, the quantity of charge uh, that applies a force of 1 Newton, that applies a force of 1 Newton on a unit charge placed at a distance of 1 meter. Okay. 1 coulomb is the quantity. Suppose this is a 1 coulomb charge. Okay. So the quantity of charge, 1 coulomb is the quantity of charge. Okay. Applying a force of 1 Newton, force of 1 Newton on a unit charge. This is also a unit charge which is placed at a distance of 1 meter. So you can write the definition. One coulomb is that quantity of charge which exerts a force of not 1 Newton, 9 into 10 to the power 9 Newton. Okay, 9 into 10 to the power 9 Newton, not a 1 Newton. So remember this. For the derivation of this we should know the Coulomb's law, and Coulomb's law is a part of the 12th class. So right now just learn this. 1 coulomb is the quantity of the charge which exert a force of this on an equal charge, or you can say 1 coulomb charge placed at a distance of 1 meter from it. Okay. Write down this.